All right, welcome to the Explainer. Today we are cracking open one of the most powerful and honestly one of the coolest features of the Geant4 simulation toolkit. Its visualization system. If you've ever felt like you're just staring at numbers and wished you could actually see what your particles are doing, well, you are in exactly the right place.
So here's what we're going to cover. First, we'll tackle the why. Why visualization is such a game changer. Then, we'll jump into the how, starting with this core idea of drivers. After that, we'll help you pick the right tool for the job, walk you through getting that first image up, and finally, we'll peek behind the curtain at some really powerful advanced features.
Okay, so let's start with the big problem. A simulation can feel like a total black box, right? You pour data in one end, you get a bunch of numbers out the other. But what on earth actually happened in between? And how can you really trust those numbers if you can't see the process for yourself?
Yeah, so how do you peer inside that box? How can you be 100% sure that your detector geometry is built correctly, or figure out why that one particle suddenly took a weird turn? This is exactly why Geant4's visualization system exists. And it's not just for making pretty pictures, not at all. It's an absolutely essential tool for debugging those super complex geometries, for tracing particle trajectories step by step, for hunting down those infamous volume overlaps, and yeah, for creating those stunning, publication-ready images for your next paper.
Now let's get into the engine room here. The real magic behind all of this is a concept called visualization drivers. And trust me, understanding this one idea is the key to unlocking the entire system.
The best way to think about a driver is, well, it's pretty much like a printer driver, but for your graphics. Geant4 knows what it wants to draw, a detector component, a particle track, and the driver's job is to translate that request into the specific language of an output system, whether that's an interactive window on your screen or a super high-res file.
And here is where it gets really clever. This modular design makes the whole thing incredibly flexible. See, Geant4 has this one universal way of describing a scene, and all the different drivers just act as translators. This means you are never, ever locked into a single tool. You get to pick the perfect one for whatever you're trying to do.
Now that flexibility is fantastic, but of course it leads to the big question. With all these options, how in the world do you choose the right driver? It might seem a little overwhelming at first, but the decision is actually pretty straightforward.
It all boils down to one simple question, really. What do you want to accomplish right now? Are you in debugging mode, just exploring, or are you preparing that final polished report?
This table breaks it down perfectly. If you want fast, interactive, let me spin this thing around exploration, OpenGL or Qt are your best friends. But if you need that absolutely perfect, crystal clear vector image for a poster or a paper, Dawn is the way to go. Need a quick, no-frills check of your geometry tree? ASCII tree will just spit out a simple text version for you. And if you want to share a 3D model with a colleague, VRML is a fantastic option.
So this really highlights the main trade-off, and it usually lines up with where you are in your research. On one side, you've got drivers like OpenGL and Qt. They're all about speed and interactivity. They use your graphics card to give you this fluid, real-time view that's just perfect for active debugging. But on the other side, you've got tools like Dawn, which put quality above everything else, producing these pristine vector images for when every little detail counts in that final presentation.
And man, the results can be fantastic. You can create these incredibly detailed and insightful views, just like this render of a detector geometry. You can see the structure, the layers, the placement. It just lets you really understand what's going on inside your setup in a way that staring at lines of code never, ever could.
Okay, let's put all this into practice. We're going to walk through how to create your very first visualization right now. And you'll see, it's a lot easier than you might think to get that first image up on your screen.
Believe it or not, getting started often just boils down to these 4 key commands. First, you open a viewer with the driver you want, something like /viz/openogl. Simple enough. Then, you draw your detector geometry. After that, you have to tell the scene you want to see the particle tracks, and then you run an event. A super common mistake here is running the beam before adding trajectories to the scene. You'll get a great view of your detector, but no tracks.
And here is a fantastic pro tip that'll get you started even faster. Almost all of the examples that come with Geant4 include a little macro file called viz.mac. Just open it up and you'll find a whole set of working visualization commands all tailored for that specific example. It's seriously the best way to see these commands in action. So once you're comfortable with those basic commands, a whole new world of control and really powerful analysis opens up. The visualization system is incredibly deep, so let's just look at a few of the more advanced features you can start playing with.
So beyond the basics, you can start asking some really surgical questions. For example, using cut views lets you slice your geometry open like a CAT scan, revealing all those internal structures that would otherwise be hidden. Or, if your scene is just overwhelmingly complex, culling lets you intelligently hide certain volumes, say everything with the density of lead, so you can focus only on what matters. And from there, you can even plot analysis histograms right inside the viewer, or create full-blown animations for your next presentation.
And for those extremely complex geometries, I'm talking about those intricate shapes you make by combining or subtracting other shapes, what we call Boolean solids, that might give other drivers some trouble. There's a special tool called the ray tracer. Like the documentation says, it can render anything that Geant4's own tracking system can navigate. It basically uses the simulation's own logic to draw the picture, which guarantees perfect accuracy.
So we'll leave you with this thought. The Geant4 visualization system, it's not just a tool. It's like getting a new pair of eyes. It gives you the power to see the unseen, to turn all that abstract data into something you can actually see and understand. So the real question is, now that you can truly look inside your simulation, what are you going to discover?